Hello, ladies and gentlemen. Welcome to Math 31, Calculus, Chapter 1, Lesson 3, Part 2, the limit of a function. So, now that we've done factoring, we can find limits. So, here, find the limit as x goes to 4 of 3x squared minus 48 divided by 4 minus x. Now, this one's sneaky. Pay attention. Oh, they're all a little sneaky. As you figured out by now, you can factor. Now, the top part becomes 3x squared minus 16 or 4 minus x, which is the limit as x goes to 4. Now that's x squared minus 16, that's x plus 4 times x minus 4 over 4 minus x. Now, so far so good? And you've seen this trick before, 4 minus x and x minus 4. This I can rewrite as minus 4 plus x, or minus 1 times 4 minus x. So this becomes the limit, x goes to 4, of 3 times x plus 4 times minus 1 times 4 minus x. Now, I will say, you guys show me you're sharp. If you want to cancel, if you want to skip some steps, I'm certainly fine with that. I really don't mind. Limit as x goes to 4 minus 3 times x plus 4. What do we got there? Well, that will equal, make x equal to 4. It's minus 3, 4 plus 4, 8, minus 24. See how that goes? Good. Now, second one's a little sneakier. Limit of x goes to 2. And notice the top is a cube. Subtract cubes. So what do? It becomes x minus 2, x squared minus 2x plus 4. No, sorry, plus. Same, different plus. Never mind. Now, you don't believe me? Double check. We just talked about factoring a difference of cubes in the previous video. Should be relatively fresh in your mind because I just made you do a whole bunch of them for homework because I'm evil and I smell funny. Now, x squared minus 3x plus 2. So that's x minus 2 times x minus 1, I think. Yes, I'm going to double check squares. Yes. And stuff cancels out, thankfully. X minus 2, x minus 2. So this becomes the limit as x goes to 2 of x squared plus 2x plus 4 over x minus 1. Now here, I plug in 2. So this becomes 2 squared plus 2 times 2 plus 4 over 2 minus 1. This is 4 plus 4 plus 4 over 1, which is 12, I believe. Now, I did that kind of quickly, but as I've said before, you should be following along. If you're copying out, pause the recording and copy stuff out. Now, limit as x approaches 2 of x to the 5th minus 32 over x to the 10th minus 1024. You notice for all of these, if we plug in the value, for this one 2, it becomes 0 over 0, which is just confusing. So stuff has to cancel out. Now, how the heck do you do that? Well, this one, if you think about it, x to the 5th and x to the 10th, that's actually x to the 5th squared minus 32 squared over x to the 5th minus 32. So this is actually a difference of squares. I agree, not immediately obvious, which is why I'm giving you a hand with it. But all of a sudden, stuff cancels out. Now, x to the 5th is 32, so that's 1 over 64, I think. All right? So far, so good? Well, I hope so. Now, here we're getting something, ouch! The limit as t goes to 0, square root of t plus 2, minus the square root of 2 divided by t. Now, if you plug the t, substitute in 0 for t, you get square root of 2 minus square root of 2 is 0, divided by 0, which sucks. So, hint, first multiply by the conjugate to rationalize the numerator. Remember the conjugate? So I multiply top and bottom by square root of t plus 2 plus square root of 2. Now, you'll see that this will be a common trick. T plus 2. Now, why are we doing that? Well, because I'm evil and I smell funny, but when I FOIL this out, my numerator becomes t plus 2 minus, plus square root of 2 square root of t plus 2 minus square root of 2 square root of t plus 2 plus square root of 2. Oh, sorry. I should have shown you the square root of t squared. Sorry. The bottom, I'm not going to FOIL. It's too much work. We're rationalizing the numerator here. Now, when we do that, this cancels out. And what are we down to? This is the limit as t goes to 0 of t plus 2 plus 2. Wait a minute. Oh, minus plus, sorry. Yes, I can hear you yelling at me. My apologies, humans. It should be minus square root of 2 squared, so that becomes minus 2. And that is t square root of t plus 2 plus square root of 2. Now, when we do that, this becomes the limit. T goes to 0 of t times and you note here, stuff cancels out. More specifically, t. And when that happens, what do we got? We have the limit as t goes to 0 of 1 over square root of t plus 2 plus square root of 2. And here I can plug in I can substitute or plug in t equals 0. That becomes 1 square root of 0 plus 2 square root of 2 square root of 2 plus square root of 2 1 over 2 square root of 2. All right? Now, that's a perfectly acceptable answer. Now, little problem. We like rationalizing the denominator. That is, we don't want to have a square root in the denominator. That's a holdover from the old days when we did logs by hand. Now it's just kind of dumb. But that becomes square root of 2 over 2 square root of 2. That's 4. Right? Now, that's what I expect you to be able to do. Is that a lot of work? Heck no. Wait till you get to some homework questions when it's 2 pages. I give you one question, and it takes you 2 pages to simplify. All right? But I'm showing you what I expect you to be able to do. Rationalize numerator or denominator. Simplify. Get stuff to cancel out. Now, here the limit as x goes to 0 of x squared divided by square root of x plus 1 minus the square root of x minus 1. So, rationalize the denominator. So for this, multiply by its conjugate base, its conjugate, x plus 1 plus square root of x minus 1. Of course, I have to multiply the numerator too. Way too much work. Let me see. So, it's x squared times square root of x plus 1 plus square root of x minus 1. Notice I'm not bothering FOILing out the numerator because by now you should see, oh yeah, stuff is going to cancel out in the denominator. So this becomes square root of x plus 1 squared plus square root of x minus 1. So x plus 1 times square root of x minus 1 minus square root of x plus 1 times square root of x minus 1 minus, because it's minus minus, never mind, x minus 1 squared. Wow, way too much writing. Which is why, at this point, I'm perfectly happy for you to go, oh yeah, those will cancel out. I don't have to write that out. I'm going to have x squared of x plus 1 squared. That's going to be x plus 1. And that's going to be minus x minus 1. Let me see. It's going to be x squared times square root of all right? Now, don't do all this work and screw up like I do. Oh, video's getting long, so I'm just going to... Okay. Minus, that be... So you get x minus x, that becomes 2. Now notice here, okay, randomly change colors on me just to confuse me. But here, notice all of a sudden your denominator exists, but you got problems because this becomes x squared, that becomes 0 squared, square root of 0 plus 1, which is fine, but careful. Your first thought is to say this is 0 because it's 0 squared, but this is the square root of minus 1, which does not exist. So there is no limit here. We cannot solve it. Okay? That's sneaky and evil, and I'm going to stop here because the video is getting kind of long. We'll finish it up in the next video. Any questions, shoot me an email. Otherwise, good luck.